Hi everyone, my name is Rachel Friedman and I'll be presenting the paper Adapting a Kidney Exchange Algorithm to Align with Human Values, which was done in collaboration with the Moral AI team at Duke University. This work was first published at AAAI in 2018 and more recently in the journal Artificial Intelligence, and I'll have a link for it at the end of the video. Okay, so imagine this. You have kidney disease and you need a kidney transplant. You have a friend who's willing to donate a kidney to you, but you're medically incompatible. Maybe they have the wrong blood type. Typically, this means that you'd have to join the waiting list for a kidney from a deceased donor, but demand far outstrips supply, so you may be waiting on this list for years, and during this time may even be put on dialysis. So this is not a great outcome for you. Now imagine that I'm in the same situation. I need a kidney transplant, I have a friend who's willing to donate to me, but we're also medically incompatible. But if my friend is compatible with you and your friend is compatible with me, then we can exchange our kidneys. My friend donates to you on the condition that your friend then donates to me. Kidney exchange matching markets facilitate this on a broader scale. There are actually hundreds or thousands of pairs like this that participate in the National Kidney Exchange Matching Market in the US. If we represent each pair as a node in a graph and draw a directed edge from node A to node B if the donor A is compatible with the patient of B, then the problem of forming exchanges like this becomes the problem of finding disjoint cycles on this graph, which we can do with linear programming. For example, here is the highest cardinality set of cycles in this graph. However, these are not actually disjoint. There's one node that participates in two of the cycles, so only one of those two exchanges can actually take place. This is important. How should the algorithm choose which exchange takes place, and therefore which participants receive life-saving transplants? This is where our work comes in. We claim that learning what participants' preferences actually are is a key part of participatory and safe machine learning. In this case, the algorithm that decides which patients to prioritize for kidney transplants should take into account the preferences of potential participants, in addition to the judgments of domain experts. Moreover, we argue that both technical experts and stakeholders, from domain experts to medical professionals to potential kidney exchange participants, should be involved in every step of this process. In this work, we propose an end-to-end methodology for gathering human judgments, incorporating them into the kidney exchange algorithm, and then evaluating the impact of these modifications on the participants in the exchange. We designed and prototyped this entire pipeline. I'll highlight a few steps here, but check out the paper if you'd like further details on the rest. An important component was asking actual human subjects, in this case Amazon Mechanical Turkers, which types of patients they thought the system should prioritize. They answered pairwise comparison questions like these. By the way, if you're interested to see how your own moral intuitions compare to our participants, come to my poster session or check out the survey link at the end of this talk to find that out. We gathered these preferences, aggregated them, modified the allocation algorithm to take them into account, and then ran 5 years of simulated daily matching using both the original and the modified algorithms. We had an expected result and an unexpected result. The expected result was that fictional patient profiles that participants tend to prefer, like this one, were matched more often by the modified algorithm than by the original. Basically, the participant preferences made a difference. However, there was also an unexpected result. The impact of the modified algorithm was felt almost entirely by the pairs that had blood types that made them difficult to match. These pairs, called underdemanded, pretty much only get matched if they had a highly favored profile. In contrast, the non-underdemanded pairs typically do get matched, even if they have a less favored profile. Crucially, the second result was not obvious from the ethical principles alone. Just as this procedure benefited from including stakeholder judgments from the beginning of the pipeline, we believe this finding is evidence that the technical experts should be involved through to the end of the pipeline to help determine the societal consequences of the systems that we help create. Thank you to my collaborators, and thank you to you for watching. If you want to find out more, you can check out the paper on the archive, check out the survey to compare your judgments against our participants, and visit my afternoon poster session at the Participatory Approaches to Machine Learning workshop at ICML 2020. Thank you!